Taking a UAV technology class and learning about drones can be difficult for many people, which is why we started off with the basics. In order to learn about the basics about drones and UAV technology class, we went on a website called the Robot Shop. Now, the Robot Shop has information about robots and drones. Now, if we go to the blog section, which is located under the community tab, you can find many different articles relating to robots and drones, how-tos, and terminology, which are written by community members and members of the Robot Shop. Now, if we click how to make a drone /UAV lesson 1 terminology, this is where we learned all the different types of terminology relating to the drones. As you can see, the top of the page shows different types of lessons and sections of this article the member created. And as we scroll down, we can see different vocabularies about the drone. At the top was the types of drones. And now we're moving on to the mechanics of the drones, which includes retract, shell, frame, connectors, clamps, and we can see little pictures of some of the vocabulary words. Now we're moving on to propulsion, control, sensors orientation, and we can see vocabulary for videos, and these are just little extra tidbits of this section. In class, after we finished with terminology, we moved on to lesson 2, which entails different types of drones and the platforms. Now, beginning with lesson 2, we can see different frame types for drones, and they include hexacopter, Y6, tricopters, octocopters, X8. And if we go more down the page, we can see different types of drone sizes and materials used to create the drone. And there is also additional considerations. Basically, this article in the blog section basically entails advantages and disadvantages of frame types, sizes, and materials used to make your own drone. Okay, so after we finished lesson 2, we moved on to lesson 3 called propulsion. And lesson 3 basically entails the most important aspects of when creating a drone. And first we see the motors, and motors include, but not limited to, the in-runner motor, brushless DC motor, and the DC pancake motor. And a little further below, down the page, we can see different types of motors and disadvantages and their advantages. And now we're moving on to the propellers, their blade diameters, angles, pitch, etc. And we can see a little bit of their diagrams, rotations. And now we see different materials that can be used to make propellers and their advantages and disadvantages. And if we move further down the page, we can see different other sections and categories which are vital to making a drone. All in all, Robot Shop was a great website for people who were new to the UAV technology world and wanted to get a more in-depth feel on how to make their own drone. We also learned about the laws and regulations of flying a drone, and we found those on the FAA.org, Federal Aviation Administration. And here you can find all of the rules and regulations that pertain to drone flying. To know more about the drones, we also had to do a project where we learned more about the cons and pros of the drones. After the basics, we started to create our own drones, and in order to do this, we used an application on the computer called SketchUp. As I mentioned, the software that we used in order to create our blueprint for a drone was called SketchUp. Now, SketchUp is a good software for anyone who just basically wants to create a blueprint for something. And in our case, we obviously use it to build our drone that we will later print from the 3D printer that was provided to us. video currently playing is not an accurate representation of how you actually start to build a frame for a drone. In order to build a frame for a drone, one has to go through the engineering design process. Engineering design process includes ask, imagine, plan, create, and improve. To start off, I ask myself questions like, what will the frame design be? How much is it going to weigh? What is it going to be made out of? How would I calculate how much the drone actually weighs, etc. Then I imagined how I actually wanted my drone to look like. Now, since this was my first time actually creating a proper frame for a drone, I wanted my design to be fairly simple because I wanted to have a good chance of it flying. So in order to actually do this, I had to plan it out, and with this came a lot of research on what material could have been used and what equations I'd have to use in order to calculate the proper weight of the frame. After extensive research, I decided to use the model m equals p times v, where m is the mass of the object, p is the density, and v is the volume. Now, of course, there will be different types of shapes in the frame. Therefore, there will be different equations for v, the volume. And v is determined by area times height. Most of the volume formulas I used were volume of pentagonal prism, rectangular prism, volume of a cylinder, and volume of a trapezoidal prism. Overall, there are many different components that can affect the overall drone weight. So therefore, a proper drone frame should be around 4 grams, because with the added on motors, propellers, receivers, batteries, the drone should have a better chance of flying. In my first attempt, the weight of my drone was 7.13 grams, which is a little off of the mark. Therefore, I tried the whole process again. I redesigned my drone. Therefore, I used different volume equations. I used a different material for my drone. And in conclusion, I came out with about a weight of 4.5 grams, which was closer to the 4 grams marks. Therefore, my drone shouldn't have a problem flying. After a drone was created, we turned it into an STL file and emailed it to our teacher, who then can print out our drone from the 3D printer. Before we actually go and put our drone together, we had to acquire the skill of soldering. And we had to acquire the skill because when we go to put our drone together, we'd have to solder the wires from the motors to the receiver. And in order to practice the skill, we drew a design on a piece of paper and tried to replicate that design with wires soldered together. The next step in our class was learning how to fly. As you can see, we learned how to fly a drone on a simulator on the TV.
Look, look. Here.